Number 1 through 3 is asking for the number of roots, looking at the functions graph. In number 1, we notice that we have 2 real roots, or 2 x-intercepts. In number 2, it appears that we have 1 real root, which we call a double root, or 1 x-intercept. And in number 3, there are no x-intercepts, so we have no real roots. We have 2 imaginary roots, 2 imaginary. So in number 5, to determine the zeros, I'm going to use the quadratic formula. So at this point where I notice that my radicand is a negative number, I know because my discriminant is a negative number, then I'm going to have 2 imaginary roots. So the first thing I'm going to do is simplify the square root of negative 20. So the square root of negative 1 is pi. Square root of 4 is 2 times radical 5. So I have 4 plus or minus 2i radical 5 divided by 2. And then what I notice is this first term and the second term and the denominator all have a common factor of 2. So when I divide each term by 2, I get 2 plus or minus I radical 5. Number 6, to find the roots of this equation, I'm going to use the quadratic formula. to this point and I notice that my radical is a negative number, then I know that my solution is going to be two imaginary roots. So I need to simplify the square root of negative 16. So the square root of 16 is 4. The square root of negative 1 is 5. What I'm noticing is in my solution I have one term, two terms, and the denominator are all divisible by the number 2. They all have a common factor of 2. So I need to simplify this expression by dividing each term by 2. Oh, let's go back. Actually, I should be dividing by 4. So sorry. Let's try that again. Yeah, they all have a common factor of 4. Let's divide each term by 4. Number 8, we have two different functions. We have the function g of x. And what I notice about the function g of x, let's see, which one is which here in this graph? It looks like g of x has a y-intercept of negative 26. So I'm going to say that this is my function g of x right here that has a y-intercept of negative 26 right there. And then my other function, h of x, has a y-intercept of positive 26. So we're asked to look for similarities and differences. So one similarity is they both open up. They both have a vertical stretch factor of 1. Some of their differences, h of x has no real roots, while g of x has 2 real roots. They have different y-intercepts, and those are some of the similarities and differences. To find the zeros of both, well, we know that h of x doesn't have any zeros that are real zeros, they're imaginary. For g of x, we're going to find 2 exact zeros, and we're going to approximate them. So I'm going to begin with g of x. And I'm going to solve this using the quadratic formula. I looked first to see if it was factorable, and you don't notice that there are any two numbers that multiply to negative 26 that add up to negative 8. I could complete the square. As a matter of fact, let's complete the square. We haven't done that in a while, and we can take a look at that process. So to complete the square, we're going to bring 26 to the right side. Take half of negative 8 and square that. Add that to both sides of the equation. We're going to factor the left side. And then take the square root or extract the root. And don't forget your plus or minus. Now, radical 42, let's see if that can be simplified. I can't think of a perfect square that goes into 42 evenly, so I think we're going to leave that as is. And adding 4 to both sides, I get 4 plus or minus radical 42. So those are my exact zeros. To approximate those, my first zero is 10.48 comma 0, and my second is negative 2.48 comma 0. So I'm going to continue down and finish answering the rest of the questions in part D. The y-intercept, if I take a look back up at my original equation, my y-intercept is at 0, negative 26. My axis of symmetry for both equations is x equals positive 4. And to find the vertex, I know my vertex has an x value of 4. So I'm going to go ahead and plug in 4 into my original function to find the partner that goes with positive 4 for x. All right, let's take a look at the function h of x. Again, I'm looking to see if that's possibly factorable, and I'm noticing again I have no two numbers that multiply to 26 that add up to negative 8. So for this one, let's complete the square on this one again. That worked out real nice last time. So 0 is equal to x squared minus 8x plus 26. So I'm going to bring 26 over to the left side. Taking half of negative 8, negative 4, squaring that, positive 16, add that to the left, add that to the right, and factor the right side. Again, we get the factors x minus 4 times x minus 4. Taking the square root, I get x minus 4 is equal to plus 4 minus square root of negative 10. So here's another imaginary solution. And to simplify this, I'm going to write this as plus or minus square root of 10 times I. And then I'm going to add 4 to both sides, so I get 4 plus or minus, and we usually write it as I radical 10. So as I go down to part D and answer the questions, there are no x-intercepts. The y-intercept is 0, 26. The axis of symmetry, again, was x equals 4. And so since my vertex is on the axis of symmetry, my x value has to be 4. And I'm going to plug that in here and substitute here to find my y value when x is equal to 4. 10, there are several ways to determine how many x-intercepts. For those of you who are visual learners and you like to see a visual diagram or a graph of this function, I notice that this function is written in vertex form. And what I do know about this particular function, it's opening up, and its vertex is at -5, -5, comma 7. So if I plot that point -5, comma +7, I get a value that looks like this. And if the problem's opening up, then I can clearly see that this function has no x-intercepts. And another way is if I were to solve this function, this would be a quadratic equation that I could easily solve by extracting the roots. So I would begin by subtracting 7 from both sides. Taking the square root of both sides. And right away I can see that I'm going to have an imaginary pair of roots, so therefore there are no x-intercepts.